Okay, this is number 2. Number 3 is asking, write a formula for the ionic compounds that form between each pair of elements here. Okay, so this is a pretty easy question. We know that they're given ionic compounds, so I know it's going to be a metal and a non-metal, right, for ionic compounds. So this should probably be asked in actually a grade 10 class here. So ionic compounds, again, I would get, so A here says I know it's calcium and oxygen here. I would get B would be zinc and sulfur. C is rubidium and bromine. And finally, D here would be aluminum and oxygen here. So basically, when we look at these problems here, there's 2 methods you can use. You can basically use the crisscross method, or you could use kind of logic in terms of how do you balance out the charges here. So I'll show you both of them. I'll show you, I guess the first 2, I'll show you the crisscross method, and then I'll show you the balance the charge method here. Personally, I like balancing the charges myself, just because crisscross method it's kind of repetitive in terms of like, oh, it's kind of the quick and dirty way to kind of like figure out the answer here, but it doesn't really actually teach you the concept of what's actually happening in terms of the atoms here. So let me look at the first one here. We have calcium and oxygen. So what we're going to do is we're going to break this down to charges here. So calcium, I'm going to look at my periodic table. As you can see, calcium lies on the second column, right? It's an alkaline earth metal. So calcium would have a charge of 2+. So Ca would have a charge of 2+. Oxygen, it's a non-metal, right? So we will look here on my right side. As you can see, oxygen here lies on group 16, which is the O here. If it's group 16, which means I will have a charge of 2-, right? I have 6 valence electrons, which means I need 2-. I need 2 more electrons to fill the octet here. So 2- here. So in order for me to solve for the ionic compound here, you could use the crisscross method. So basically Ca2, the 2+ here charge will become the coefficient for O2- here, and the 2 here would also become the coefficient for the Ca here. So you get Ca2O2, and you can simplify this even further to just simply CaO, right? Because these 2 can reduce to 1 here, and you get CaO, or calcium oxide here. So that's the correct solution for my first answer here. I can do the exact same thing for zinc and sulfur, right? So if I look at my periodic table, zinc is actually zinc here is kind of a special metal where it's multivalent, right? So when we talk about zinc as being a multivalent compound here, it's going to have basically more than 1 charge. In this case, we don't really have a charge here. So I'm going to assume that it's 2+, which is the most common charge for zinc here. And let me try to find zinc for you. Zinc is here. Zinc, because group 12, again, have a charge of 2+ here. So I'm going to assume zinc here has a charge of 2+. And then sulfur here, if I look at my periodic table, sulfur here lies over here, right? This group 16 again, I have it's under group 16. Sulfur here will have a charge of 2-, right? 2- here. I can then employ the crisscross method. So my coefficients the charges become the coefficients of the opposite element, which means I'm going to get Zn2S2, which I can simplify further to Zns, right? So zinc sulfide here will be my correct answer, or zinc 2 sulfide would become my answer for this problem here. So that's the crisscross method. I'll show you the one I use, and this is the one that I kind of like balancing out the charges here. So I have rubidium and bromine here. So let me go back to my periodic table. Rubidium relies on the first column here in the metal section, and as you can see, rubidium here relies on group 1, which means rubidium would have a charge of 1+. So let me write down rubidium here. So Rb would have a charge of 1+. Same with bromine here. Bromine is a nonmetal. It's going to lie on group 17 here. It's a halogen, and it's going to possess a charge of 1-, right? So Br would have a charge of 1-. And what I'm going to do is, instead of crisscrossing, what I'm going to do is I'm going to think about this logically. I'm going to think about how do I balance out my charges to get a net charge of 0. If I want to get a net charge of 0, I have 1+ here and 1- here, right? So 1 + 1 + -1 will give me a charge of 0, which means I don't need to add any coefficients here in order to make my charge 0. So in this case, I can just simply write out Rb Br would be my answer here. It's just simply I only need one of each atom for me to balance out the charges here. So that's going to be my correct answer for C. And finally, aluminum and oxygen, right? So I'm going to look back at my periodic table for aluminum. And aluminum lies under here, right? Under group 13 here. So this here is Al. Well, it's going to have a charge of 3 plus here. So aluminum, so I'm going to write Al here, has a charge of 3 plus. And we know the oxygen from before here, oxygen here has a charge of 2 minus, right? So I'm simply just going to write 2 minus here. Oh, 2 minus. And again, I want a net charge of 0, right? If I want a net charge of 0 here, I have 3 positives and I have 2 minuses here, right? If I add the two numbers up, I'm going to get a net charge of positive 1, which is no good. I want a charge of 0, right? So in order for us to do that, how I think about this problem here is I can think about using lowest common denominator. So in order for me to get the lowest common denominator between 3 and 2 here, this would be 6, right? I would get a lowest LCD here of or I guess it would be greatest common factor. Would be 6 here, right? So if I wanted to get that, I would basically have to add a 2 in front of aluminum and a 3 in front of oxygen, right? This makes it so that's 2 times 3 plus here, which means aluminum would have a charge of 6 plus, and 3 times 2 minus here, which will give me a 6 minus here. 6 plus minus 6 will give me a net charge of 0. So therefore, I'm going to only need aluminum has to have 2, I have to have 2 aluminums here, and then oxygen will have 3 here, right? So this is Al2O3, which is aluminum oxide. So these are my correct answers here. So I'm going to have, again, CaO, ZnS, RBBr, and Al2O3. So this will be my correct answer for this problem here. This is a very, very long solution. And I don't think they actually added my... I don't think they actually wrote the chemical equations. This is actually, again, another incomplete solution. I'm just going to write it down here. So AB was... calcium, oxygen, and oxygen make calcium oxide. So CaO. B is zinc and sulfur make zinc sulfide. This is ZnS. C here is rubidium and bromine make rubidium bromide, which is RBBr. And finally, D here is aluminum and oxygen make aluminum oxide, which is Al2O3 here. So this here is my incomplete solution. There's great logic behind it, but they forgot the chemical formulas for the ionic compounds. So I'm just going to say a solution is incorrect just so they can add this into the system here.